welcome to Joy Home. So this is Computer Graphics and Image Processing Module 1 Part 7. So in this video, we will be discussing about color CRT monitors. See, a cathode ray tube monitor displays color, is a subheading, starts from here. Displays color pictures by using a combination of phosphors that emit different colored light. So if the phosphor can emit different colors of light, we can display color pictures. By combining the emitted light from the different phosphors, a range of colors can be generated. See, so by combining different colors, we can combine the emitted light, and from that different phosphors we can create a range of colors. And the two basic techniques for producing color displays with a CRT are the beam penetration method and the shadow mask method. So to produce color display, we have two ways. One is beam penetration method and the second one is the shadow mask method. Beam penetration, shadow mask method. Now what is the beam penetration method? The beam penetration method for displaying color pictures has been used with random scan monitors. In the previous video, we have discussed what random scanners. So, random scan monitors. Using the random scan monitors, we can do beam penetration method. Two layers of phosphor, usually red and green, are coated onto the inside of CRT screen. And the displayed color depends on how far the electron beam penetrates into the phosphor layer. So, we have a combined color of red and green. In the raster scan 1, we have green and we have red. So, these are coated inside the CRT screen. Inside the CRT screen, they are coated. Inside the CRT screen, they are coated. And the displayed color. The color that we get, the color which is displayed will depend on how far the electron beam penetrates into the phosphor layer. So these electron beams which emit, how far will it penetrate into the phosphor layer? So see, this one is a phosphor layer, right? So how far will these light penetrate into it? That is what it determines. The color is depending on the penetration into the phosphor layer. A beam of slow electron excites only the outer red layer. Now, if the electrons are slow, it will excite only the outer red layer. Now, a beam of very fast electron penetrates through the red layer and excites the inner green layer. If the electrons are slow, it will only excite the outer red layer. Only the outer red layer will be excited. But if the beam of electrons are fast, then it will penetrate through the red layer and will excite the inner green layer. At intermediate beam speeds, combination of red and green light are emitted. So then these two colors, that is red and green light, will give us two additional colors, that is orange and yellow. The speed of electrons and hence the screen color at any point is controlled by the beam acceleration voltage. So, two things. The speed of the electron and the screen color is controlled by the beam acceleration voltage. Beam penetration has been an inexpensive way to produce color in random scan monitors. But in this case, only 4 colors are produced. We have red, green, orange, yellow. We have only 4 colors, right? And the quality of pictures is not as good as with other methods. Okay, so which one was this? This was beam penetration, from the word itself, beam penetration method. And look, this is the figure for beam penetration method. A random scan system draws the component lines of an object in any order specified. So this is beam penetration method which uses random scan monitor. So what is the next one? Shadow mask method. shadow mask method are commonly used in raster scan system. So here, shadow mask method, this much we have to write, okay, for beam penetration. Now for shadow mask method, we have raster scan system. Color TV is an example because they produce a much wider range of colors than the beam penetration method. Because in beam penetration, we only have 4 colors, okay, but in shadow mask method, we have wide range of colors. A shadow mask CRT has 3 phosphor color dots at each pixel position. So they have 3 phosphor color dots at each pixel position. One phosphor dot emits a red light, another emits a green light, and the third emits a blue light. Okay, now we have blue lights, we have a green light, and we have a red light. Okay, now we have 3 colors. Okay, this type of CRT has 3 electron guns. So in this, we have 3 electron guns, one for each color dot. So for each color, we have 3 different electron guns. And the shadow mask grid just behind the phosphor coated screen. So behind the phosphor coated screen, we have a shadow mask grid. Okay, now figure 210 illustrates the delta shadow mask. So this is the figure. The operation of a delta shadow mask. See, we have 3 electron guns for blue. This one is for blue, we have for green, and for red. We have 3 electron guns. And then we have the screen. See, all the 3. It forms a triangular phase over here, right? This is a magnified phosphor dot triangle. So it forms over here. Look over here. It is in the form of a triangle, right? So the 3 electron guns aligned with a triangular color dot patterns on the screen are directed to each dot triangle by a shadow mask. We'll learn about it. So this is the delta shadow mask method, commonly used in color CRT system. The 3 electron beams are deflected and focused as a group onto the shadow mask, which contains a series of holes aligned with the phosphor dot patterns. See here, selection of shadow mask, and we have dots over here, we have holes over here, right? Okay. Now, when the 3 beam passes through a hole in the shadow mask, they activate a dot triangle. Appears as a small spot on the screen. The phosphor dot in the triangles are arranged so that each electron beam can activate only its corresponding colored dot when it passes through the shadow mask. Now, another configuration for the 3 electron gun is an inline arrangement. So, this one was a delta shadow mask. Okay, delta shadow mask we studied just now. Then we have the inline arrangement, in which 3 electron guns and the corresponding green-blue colored dots on the screen are aligned on a one scan line instead of a triangular pattern. So in delta we have a triangular pattern. This is for delta. And for the inline method, we have it in a single line. This is an inline arrangement. This inline arrangement of electron guns is easier to keep in alignment and is commonly used in high resolution color CRTs. So inline arrangement we are using for higher resolution CRTs. This whole paragraph is important. We obtain color variations in a shadow mask CRT by varying the intensity level. So in the shadow mask CRT, we will get different variations of colors by varying the intensity levels of the 3 electron beams. We have 3 electron beams for green, blue, and red. So for these 3 electron beams, for these 3 electron guns, we will be changing the intensity. Now, by turning off the red and green guns, we get only the color coming from the, if we turn off red and green guns, then we will only get the color of blue phosphor. Now, other combinations of beam intensities produce a small light spot for each pixel position, since our eyes tend to merge the 3 colors in one composite. The color we see depends on the amount of excitation of the red, green, and blue phosphor. Now, if you are having a white or gray area, is a result of activating all. So, if all the 3 colors, if we are having all red, green, and blue are having equal intensity, we will get a white or a gray. That is a color combination. Now, yellow is produced with the green and red dots only. Magenta is produced with the blue. So these are different color combinations, and we have several million different colors to be generated. The color graphic system can be designed to be used with several types of CRT display devices. Some inexpensive home computer systems and video games are designed for use with a color TV set and an RF, that is radio frequency modulator. Then we have now this one you can write in here. Now, composite monitors are adaptations of TV sets that allow bypass of the broadcast circuitry. Now these display devices still require that the picture information be combined, but no carrier signal is needed. Now color CRTs in graphics systems are designed as RGB monitors. These monitors use shadow mask method and take the intensity level of each electron gun, that is red, green and blue, directly from the computer system without any intermediate processing. High quality raster graphics systems have 24 bits per pixel in the frame buffer, allowing 256 voltage settings for each electron gun and nearly 17 million color choices for each pixel. An RGB color system with 24 bit storage per pixel is generally referred to as we call it as a full color system or a true color system. That is, an RGB color system which is having 24 bits per pixel is what we call a full color system or a true color system. Okay. Now, moving on to the notes. We have a CRT monitor displays color pictures by using combination of phosphors that emit different colored light. By combining the emitted light from the different phosphors, a range of colors can be generated. The two basic techniques for producing color displays with CRT is the beam penetration method and the shadow mask method. Now, in beam penetration method, two layers of phosphors, usually red and green, are coated onto the inside of the cathode ray tube screen. Displayed color depends on how far the electron beam penetrates into the phosphor layer. This is a proper figure. We have the electron beam. The fast electrons passes through the red and reaches the green. The slow electrons reach till the end. So this is the screen, the green phosphor coat and the red phosphor coat. A beam of slow electrons excites only the outer red layer. Slow electrons will only reach to the outer red layer. Now, a beam of very fast electron penetrates through the red layer and excites the inner green layer. At intermediate beam speeds, combination of red and green lights are emitted to show two additional colors, orange and yellow. Now, the advantage of this one is it is an inexpensive way to produce color in random scan monitors. Okay, inexpensive way. But the disadvantage is only 4 colors are possible. What are colors? We have green, red, orange and yellow. And the quality of picture is not as good as with other methods. Then we have the shadow mask method. Shadow mask method CRT has 3 phosphor dots at each pixel position. One phosphor dot emits red, then we have green and blue. This type of CRT has 3 electron guns, one for each color dot, and a shadow mask grid just behind the phosphor coat screen. Now, 2 types of arrangement are possible in shadow mask method, that is delta-delta method. It is called the triad arrangement and inline method. In delta-delta method, it is commonly used in color CRT system. We have red, green, blue, 3 electron guns. The electron beam passes through the selection area. This is shadow mask. And this is screen with RGB phosphor dots. It forms a triangular way. That's why it is called as delta-delta method or triad arrangement. A shadow mask is often used to ensure that the electron beams from the gun falls on the correct phosphor. It has to fall on the correct phosphor. Now, the 3 electron beams are deflected and focused as a group onto the shadow mask. When the 3 beams pass through the hole in the shadow mask, they activate a dot triangle which appears as a small spot on the screen. The phosphor dots are in the triangles are arranged so that each electron beam can activate only its corresponding color dot when it passes through the shadow mask. Then color variations in a shadow mask CRT are obtained by varying intensity levels of the 3 electrons. See, we have green, blue and red and different varieties. Now, if blue, green, red, all these have equal intensity, then we will get white as a color or gray as a color. Then coming to inline method. Here, 3 electron guns and the corresponding red, green, blue color dots on the screen are aligned one tan line rather than in a triangular pattern. In the delta-delta method, we have it in a triangular method, that's the triad arrangement. But in inline method, we have it in a single line. Thus, inline arrangement of electron gun is easier to keep in alignment and is commonly used in high resolution color CRT. So, the inline method is used in high resolution CRT. This is the triad method and this is the inline method. Now, okay. Delta-delta method is used in color CRT system and inline method is used in high resolution color CRT system. Now, in some low-cost system, the electron beam can only be set to on or off, limiting displays to 8 colors. More sophisticated systems can set intermediate intensity levels for the electron beams, allowing several million different colors to be generated. Now, color CRTs in graphic systems are designed as RGB monitors. These monitors use shadow mask method and take the intensity level for each color. At RGB color system with 24 bits of storage per pixel is what we call as a full color system or the true color system. Now, the advantages of color cathode ray tubes. Their advantages are produce realistic images, million different colors to be generated, shadow scenes are possible. But the disadvantages, it is expensive and it is having less resolution. Now, beam penetration method and shadow mask method different. See, in beam penetration method, where is it used? It is used with random scan system to display the color. Beam penetration, the first one we have learned. So that is random scan system. Shadow mask method is used with raster scan system. Now, the color, beam penetration can only display 4 colors. Red, green, orange, yellow. Shadow mask method have millions of colors to display. Color dependency. In beam penetration, less colors are available because the colors in beam penetration depends on the speed of the electron beam. So, it is depending upon the speed of the electron beam. That is why beam penetration method. So, less colors are only available. But in shadow mask method, millions of colors are available because colors in shadow mask depend on the type of the ray. It's depending on the type of the ray. In beam penetration, it is depending on the speed of the electron beam. Then the cost, beam penetration is less expensive, but shadow mask method is more expensive. Quality is not so good, poor with beam penetration method. Shadow mask method gives realism in picture with shadow effect and millions of colors. Now, resolution, beam penetration have higher resolution. The quality is not good, but it is having higher resolution. Now, in shadow mask method, the resolution is low, but it gives realism in picture with shadow effect and millions of colors. Now, criteria. In beam penetration method, color display depends on how far electron excites outer red layer and the green layer. That is the criteria. But in shadow mask method, there is no such criteria for producing colors, and it is used in computers, in color TVs, etc. Okay, now that's it about the half of the module is over. We did color CRT display. Now in the next video, we will be looking about the algorithms. Okay, line drawing algorithms. So then, bye-bye.